Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 12, Nonlinear Models in a Data Context. Okay, so here we go. Example 1, growing dahlias. A dahlia is a type of flower. A group of students wanted to determine whether or not compost, fertilizer, is beneficial in plant growth. The students used the dahlia flower to study the effects of composting or fertilizing. They planted 8 dahlias in a bed with no compost and another 8 plants in a bed with compost. They measured the height of each plant over a 9-week period. They found the median, that is a measure of central tendency where you may have some skewed data. We would use median instead of the mean. So they found the median growth height for each group of 8 plants. The table below shows the results of the experiment for the dahlias grown in non-compost beds. So these are the non-compost beds, plain old soil, no compost, and there's the 9 weeks, and there's the amount of growth. So the median height in non-compost beds in inches, and exercise number 1 says on the grid below to construct a scatter plot. Okay, so if this is our independent variable, and this is our dependent variable, x and y, then this will be our x weeks and our y height. Okay, for starters, I just wanted to mention that. So weeks is our x and y is our height. I'll put it down here because I can't see it the way it's scrolled. Okay, so we're going to plot these points. 1, 9. Okay, so 9's, it's roughly right there, just below 10. And 2, 12.75. 10, 12.5 would be here, so a little bit more, so right there. Number 3 is 16.25, so here's 15, here's 17.5, so 16.25 might be about there. Let's see, number 4, 19.50, 19.5, so here's 15, 17.5, 19.5 is just under the 20. And number 5 is 23, so here's 22.5, so just above. And number 6 is 26.75, which is just about here. And 730, that's an easy one, finally an integer value. And 8 is 33.75. So this is 30, this is 32.5, 33.75 is just about here. And finally 9, 37.25. 37.5 is here, just under. And there is our scatter plot for non-compost data. Those are the medians. Okay, so that's number 1. All we had to do was plot x and y, bivariate data. Now number 2 says to draw a line that you think fits the data reasonably well. So I go back. Obviously, if I'm going to draw a line, it's got to be straight. So I'm going to bring my ruler with me. And if you're doing this on your paper, always use a straight edge. Do not just draw a line that squiggles around and isn't accurate. Okay, so I'm looking at my data points here. So if I line it up with the first and the last, actually this data is pretty darn close to a perfect straight line. So my line of best fit, I'll use green so you can see it, is going to be right here. There is my line of best fit. Those data points are pretty close. That's pretty strong correlation. 3 says find the rate of change for your line. Interpret rate of change in terms of growth and height over time. So rate of change is a change in y over change in x. We call our slope of our line rate of change. And what I like to do is choose values that are right on the number line. So here is a point that appears to be right on the line, and here's another one here that appears to be right on the line. So that is the point 1, comma, and I'm going to use the values from the table so I'm accurate. I'm using the point 1, 9, and that will be my first point. And then my second point is going to be this other point over here, which is 8, 33.75. Okay. Okay, so I brought those values over here, and now I'm going to calculate my rate of change, and I'm going to use the variable m to represent rate of change. And the rate of change is your y2 minus your y1 divided by x2 minus x1. So my rate of change is going to be y2. So let me label these just so, okay, this is my first point, and there's my x, and there's my y. And this is my second point. Here's my x, and here's my y. So when I am saying y2, I'm talking about the y value in my second point, which is 33.75. And I'm going to subtract my y1, which is the y value in the first point, which is 9. And I'm going to divide that by my x2, which is my x from my second point, which is 8, minus my x from my first point, which is 1. So when I do that, I get 7 in the denominator. 8 minus 1 is 7. 33.75 minus 9 is 24.75. Okay. Okay, so 24.75 out of 7. Now it says to find the rate of change. There it is. Interpret that rate of change in terms of growth and height over time. Well, this means how much it grew in 7 weeks. So if I divide that by 7, on average, we'll find out how much per week it grows. So I brought the calculator in, and 24.75 divided by 7 is approximately 3.5 weeks. So 3.5. So that is approximately 3.5. And if I go back to my table, it is inches per week. Okay, 3.5, approximately 3.5 inches per week, those grew. Number 4 says to describe the growth change in height from week to week by subtracting the previous week's height from the current height. Record the weekly growth in the third column in the table below. The median growth for the dahlias from week 1 to week 2 was 3.75 inches. So they took 12.75 minus 9. This is blank because 9 minus 0 is just 9. And at week 0, I guess you could put 9 in there. It grew 9 inches the first week. Okay, so that's all we're doing here is subtracting the value in inches from the previous week's value in inches. So 5 minus 5 is 0. 2 minus 7, well, that'd be 12 minus 7 is 5. And I had to borrow from the 6, so that's now 5 minus 2 is 3. So that grew 3.5 in this second to third week. 0 minus 5, if that was 10 minus 5, that'd be 0. And I had to borrow from the 5 to make it 4. 4 minus 2 is 2. 9 minus 6 is 3. So it's 3.2. Okay, week 5 from 4, 0 minus 0 is 0. 10 minus 5 is 5. To get that 10, I had to borrow from the 3, so now that's a 2. Or 12 minus 9 is 3. And then that 2 became a 1, so that's 3.5. 5 minus 0 is 5. 7 minus 0 is 7. 6 minus 3 is 3, and 2 minus 2 is 0. 0 minus 5 is 5, or 10 minus 5, I should say. So that would make this a 9. 9 minus 7 is 2. And that would have made this 0 a 9. 9 minus 6 is 3. 5 minus 0 is 5. 7 minus 0 is 7. 3 minus 0 is 3. 5 minus 5, 0. 12 minus 7, 5. To get 12, I took from the 7, made it a 6. 6 minus 3 is 3. So there we have it. Let me get rid of that. So 3.5, 3.2, 3.5, 3.75, 3.25, 3.75, and 3.50. So number 5 says, as a number of weeks increase, describe how the weekly growth is changing. So as the weeks increase, the weekly growth, it grew 3.75 the first week, but then it only grew 3.5. Then it slowed down some more, but then it speeded up again, then slowed down, then speeded up, then slowed down. So it's all over the place. Okay, but if we're talking about height in inches, then they're all 3s, and they all range from 2 to 7, so that's a ½ an inch. So roughly, it's right around 3.5 inches, give or take a ½ an inch. So pretty much consistent. Let's call it that. Let's say approximately consistent. and it's about 3.5 inches. How does the growth each week compare to the slope of the line that you drew? Well, the slope of the line that we drew, if we go back, we found it to be, actually I did it on the same page just above, it came out to be 3.5 inches per week. Okay, so how does that growth each week compare? It's about the same. Okay. The amount of growth per week varies from 3.25 to 3.75, but centers around 3.5, which I have already said, and I'm not going to write that. And number 7, estimate the median height of dahlias at 8.5 weeks. Explain how you made your estimate. Okay, so I will go back to the graph, and they said 8.5 weeks. So what I'm going to do is take my ruler and make it vertical, bring it over halfway between 8 and 9. Okay, here's 9, here's the 8's there, so halfway's about there, and I'll draw a line up until I get to that green line. Because if we're going to use a line of fit, we're going to use it to approximate. And I'm going to bring this over. I'm going to put it right where that red line meets the green, right here. And I'm going to draw a line over here, and that is going to tell us the y value when x was 8.5. And it's a little more than 35. So I'd say about 35.5 would be my approximation. So when I go back here and answer that question, estimate the median height, I would say it's approximately 35.5 inches. Okay, the table below shows the results of the experiment with the dahlias grown in compost beds. So now we're using fertilizer. So let's see what the difference is with the fertilizer. So I'll drag this up, and I'm going to do exactly the same thing. This is x, this is y, this is x, this is y. And I'll use green for the graphing. 1, 10 is right here. 2, 13.5, here's 15, 13.5 is about there. 3, 17.75 is a little more than 15, halfway between 15 and 20. And 4, 21.5 would be approximately here. And 5, 30.5 is here. And 6 is 40.5, so right about here. All right, and 7 is 65. I have a feeling compost is a better go if you want large dahlias. 8, 80.5, 80.5, so right about here. And number 9 is 91.5, which is approximately there. Okay, so now look at our graph. Do the data appear to form a linear pattern? And I would say no. It curves. That's a U. Okay, it is curving up, but then it's kind of curving, it's slowing down again. It's starting to curve here, because obviously no plant just grows forever. It's eventually going to slow down and stop at a maximum point somewhere. Number 10, describe the growth from week to week. So this is a copy. All we're doing is subtracting this value from the previous. So 5 minus 0 is 5. 7 minus 5 is 2. And 7 minus 3 is 4. So this one I need to take away from the 5. 10 minus 5 is 5. And this is now 4, or 14, minus 7 is 7. And that becomes 20 minus 17, which is 3. 0 minus 0 is 0. Get rid of this. 5 minus 5 is 0. 0, or make that a 2 and bring out a 10. 10 minus 1 is 9. Okay, erase that. Next one. 0 minus 0. I'm sorry, 0 minus 0. I'm doing 6 minus 5. 0 minus 0 is 0. 5 minus 5 is 0. 0 minus 0 is 0. And 4 minus 3 is 1. So that was a total of 10 inches. 0 minus 0, 0. Take from that 5, make it 4. Make that 10 minus 5 is 5. 4 minus 0 is 4. And 6 minus 4 is 2. erase that so I can use it on the next one. 0 minus 0 is 0. 5 minus 0 is 5. 10, make this a 7 and borrow. 10 minus 5 is 5. And 7 minus 6 is 1. So as you can see, it did slow down there. And 0 minus 0 is 0. 5 minus 5 is 0. 1 minus 0 is 1. And 9 minus 8 is 1. So 10. Oh, it's 11.11. 11. So it went 4.25. Then it slowed down a little to 3.75. And then it went to 9. And then it increased to 10. And then it increased to 24.5. And then it increased to 15.5, and then it increased 11. Okay, now it says, as the number of weeks increased, describe how the growth changed. Okay, well, this is an increase to here, so this is an increase. And then here, let me change colors. From here to here, it was a decrease. But then, from 3.75, it increased 9, 10, 24 to there. That was an increase. All right, and then from 24 down to 15.5 down to 11 is also a decrease. So it increased, then decreased, then increased, then decreased. So the growth is fluctuating. Number 12, sketch a curve through the data. When sketching a curve, do not connect the ordered pairs, but draw a smooth curve that you think reasonably describes the data. Okay, so I'm going to go back to the graph. And if I were to graph a curve, it would kind of be going like so. And then it kind of curves up like that. So we got a point here that's above our smooth curve, and we got a point over here that's below. Okay, so there is an approximation of my curve. It might not even grow that quickly either. It might be a better approximation if I go this way, and maybe not so much that way. All right, and what point did I erase? 80.5. Put that back. Okay, so maybe more like that. So there's our curve. Okay. Use the curve to estimate the median height of a dahlia at 8.5 weeks. So I'm going to go back to what I just curved, and I'm going to get my ruler again, and I want to graph 8.5 weeks. Okay, so I brought my ruler in. Let me draw a line. I've got it set at 8.5. I draw a line up to my approximation, and then I bring my ruler down like so, and I move it over here right up to where it hit that curve, right about there, a little higher, and that's the value I'm going to end up with over here, just under 90. So I'd say about 89. Okay, so approximately 89 inches at 8.5 weeks. And my explanation is my visual that I just showed you on the graph. Number 14 says, how does the weekly growth of the dahlias in the compost beds compared to the weekly growth of the dahlias in the non-compost beds? Okay, that one I'm going to bring in as a text. Okay, so the growth in the non-compost is about the same each week. It looked like it was pretty consistently linear. The growth in the compost starts at the same as the non-compost, but after 4 weeks, the dahlias begin to grow at a faster rate. Okay. Number 15. When there is a car accident. Okay, so now problem 15 is talking about car accidents. When there is a car accident, how do the investigators determine the speed of the cars involved? One way is to measure the skid marks left by the cars and use these lengths to estimate the speed. The table below shows data collected from an experiment with a test car. The first column is the length of skid marks in feet, and the second column is the speed of the car in minutes per second. So I'm going to drag this down, and it doesn't quite fit, so I'm going to have to scroll at first, but then I'll go back. Okay, so first of all, we want to construct the scatter plot. So these are my x's, my independent variables, skid marks in feet, and y is the dependent variable, and that is speed, miles per hour. So the longer the skid mark, the faster they were going, is what we would assume. So number 5, 5-foot skid mark, 10 miles per hour. So I'm going to go over to 5. Well, this is 50, this is 25. So if I broke this into 1, 2, 3, 4, 5 even, let me try that again, that's not very good. So if I broke this into 5 even marks, like so, 1, 2, 3, 4, 5. Actually, I'd only want 4 in between. So let's try that again. We just want to be fairly accurate. So if this is 25, then this would be 20, 15, 10, 5. Okay, so we have the skid mark 5 feet, 10 miles per hour. So 5, 10 would be way over here since we're using a scale of 50, like so. The next one is 17. So once I get past that first one, I don't have to scroll anymore. So now 17, 20. 25, so this is 5, 10, 15. So 17 is right about here, and that is 20 is right here. And then finally we're going over here, 65. Well, this is 75, so it'd be about here, and 65 is 40 miles per hour, so that's right here. Okay, and then 105 feet is 50, so just over 100 is 50, so right about here. Okay, 205 feet is 70. So 200's here, 70's here, 205 is here. 265 is here, and we're coming out to 80 miles an hour. So 265 is there. So as you can see, it's not a straight line. It does look like a curve, and that's finally going to be answering the next question. So the scatter plot is constructed. The relationship between speed and skid mark lengths can be described by a curve. Sketch a curve through the data that best represents. So now I want to draw a curve through that. So it's going to come up like so and over like that. Okay, something like that. Okay. Remember to draw a smooth curve that does not just connect the ordered pairs. So as you can see, I am not on the line, not on the line, not on the curve, and not on the curve here. Part C says, if the car left a skid mark of 60 feet, what's an estimate for the speed of the car? So now it's saying 60 feet. So now it's the same. You get a ruler, and you make an approximation using your curve that you drew. So turn the ruler perpendicular, and they said 60 feet. So I'm going to bring the ruler over to 60 feet. So 75 is here, 60 feet would be about here. So let me change colors. So if I draw a line up here, rotate this down to level like so, and then go straight across from the point it hit the curve over to here. There is my approximate value right there, which is, here's 30, here's 35, so I'd say about 37 or 38. I'd say approximately, what is the estimate of the speed of the car? About 38 miles per hour. D says a car left a skid mark of 150 feet. Estimate the speed at which the car was traveling. So 150 feet this time. So I'm going to bring my ruler back down, bring it vertical, go over to 150, which is right here. So I go up to 150, it's this point right here, And then when I rotate this, then it goes over here, and it's just above 60 miles per hour, so I'll say 61. I'll say approximately 61 miles per hour. Part E says, if a car leaves a skid mark that is twice as long as another skid mark, was the car going twice as fast? Explain. So I'll go back to this grid, okay, and now I'm going to get rid of these, or actually I could just move them. And so let's see, let's move this to 200, which would be here, and move this one to 100. So actually that won't work, so it'd be easier. I just don't want to erase my line, so let me just move all these out of the way. And let's draw a line that is at 200. It's purple this time. Put that right on 200 and draw a line up to here and then rotate it around. Okay, so I'm just picking easy numbers that are integers and that are on the grid. Okay, so as you can see, that's approximately 71 miles per hour, 200. So then I want to do another line that would be half of 200 and confirm whether or not it was half the speed. That's what we're trying to determine. So if I draw a line up to there, bring this down, draw a line over from where it makes contact to that curve, which is right here, and it's just under 50 miles an hour, so I'd say 49. Okay, so I have 71 and 49. So I'm going to draw those as, write those as ordered pairs. So it's going to be 100 comma 49, and let me bring that down to E. So we have the point 100 comma 49, and we have a point 200 comma 71. Just had to look there. So 200 comma 71. So this was the feet, and this was the miles per hour. And this is the feet, and this is the miles per hour. So it says, if a car leaves a skid mark that is twice as long, so 200 is twice as long as 100, was the car going twice as fast? Well, 49 times 2 equals 98, and this is only going 71, so my answer is no. And there's my explanation. Okay, that is the end of Lesson 12. Review the lesson summary and go do your problem set.